Here I redraw the diagram, and let's call this upper wire to be the wire 1 and the wire at the lower side to be the wire 2. We are asked to determine the magnetic field at this point P. So here is given this is the current is out of the patch. So by using the right hand rule, we are able to determine the direction of the field that produced at this point P. At point P, this wire 1 will produce the magnetic field B1 somewhere here, and this wire 2 will produce the magnetic field B2 to be somewhere here. So since this is the magnetic field vector, that means we also have to find out the direction. But before we find out the direction, let's solve for the magnetic for each magnetic field due to each wire. So we know this B1 will equals to mu naught I over 2 pi R1. Now this R1 is the distance between the source until this point P. So we just substitute the value. Current is given. This R1 is 6.0, 10 to the negative 2. Here I get this is 1.17, 10 to the negative 4 Tesla. And we do the same for the B2. I over 2 pi R. This is 2 pi, and now the distance is 10 to the negative 2 equals to 7.0, 10 to the negative 5 Tesla. Now this is the magnetic field due to the each wire. So until now we have to solve for the angle. Let's say the angle here is delta 2, and the angle here is delta 1. Now we know this B2 must be perpendicular to this R2, right? So we know the angle here is also given by delta 2, and the delta 1 here is actually will be the same as the angle here. This is delta 1. Now how do we solve for this delta? For me, I will let this line here to be the, let's say A, the distance from here to here to be A, and the distance from this wire 2 until this A be, let's say C. So we know the upper part here is given by 1, 3 minus c. And the angle here is 90 degrees. So let's see the triangle. So we have the 10.0 square equals to the c square plus a square. Now we look at the upper triangle. We know this is 6.0 square equals to 1 3 minus c square plus the a square. So we rearrange this a square, we get 10 square minus c square. We substitute this thing inside here. We get the 1 3 minus c square plus 10 square minus c square. Now we solve for this. 169 minus 26c, and this is plus c square. Now plus 10 power of 2 minus c square. This thing will cancel out. So this is 6.0. Now we can solve for this c. The c I get is the 8.962 cm. So from here we know the sine theta 2 is equals to a over the 10, and the cos theta 2 is equals to this c over 10. Now we already solved for the c, so we can find out the theta 2. This theta 2 is given by 26.3 degrees. Now we apply this formula here. We already know the theta 2. We can solve for the a. Just substitute the value inside for this theta 2. So I get this is 4.431 cm. From here we can solve for the theta 1. We know the sine theta 1 is equals to this a over the 6.0. A is a 4.431 over this 6.0. We solve for this theta 1. I get this is 47.6 degrees. Now we already have a theta 1 and a theta 2. We can solve for the magnetic field in each direction. So let's solve for the magnetic field in the x direction first. From the diagram here, the x direction, this is the x and this is a y. So first thing, the b1, cos data 1 to give us the x component. And you can see this b2 here, this is pointing toward a negative x direction, so we put a negative b2 cos data 2. So b1 we get is a 1.1710 to the negative 4, and cos data 1 is a 47.6 degrees minus 7.0 10 to the negative 5 cos to 6.3 degrees. I get this is a 1.614 10 to the negative 5 Tesla, and By is equals to B1 sine data 1, and they are both in the positive x direction, so plus B2 sine data 2, right? This is equals to 1.1710 to the negative 4 sine 47.6 degrees plus 7.010 to the negative 5 and sine 26.3 degrees. I get this is a 1.174 10 to the negative 4 Tesla. So to find the net uh, magnetic field, we get bx squared plus by squared, square root the whole thing. I get this is a 1.185 10 to the negative 4 for Tesla. Now this is the magnitude of this magnetic field at the point B. Now as usual we have to solve for the this direction data. So arctangent will be by over bx, and we already solved for these two, so we just substitute inside. One point. So this direction is at 2.2 degrees. From the positive x axis. So direction I add here, this is 2.2 degrees from positive x axis.